Hello, this is Mr. Stansbury. I'm going to take you through the 12B notes on sequences of numbers. At the end of this, you should be able to say I can find the terms of arithmetic and geometric sequences when given the general term, which is the formula. Okay, so with that, we're going to kind of look at an example here to help you better understand the sequences of numbers. So if u, and that's called u sub n because it's a little subscript here. So u sub n represents the number of bricks in row n from the top. Then u sub 1, u sub 2, and u sub 3 would all equal what? So again, u sub 1, this n here is standing for the number, like whichever row it is. So since this n here is now replaced with a 1, that means we want to know how many bricks are in the first row. So there would be 3 in the first row. And then u sub 2 would be the second row, so there is 4 in that row. And then u sub 3 is the third row, which there are 5 in that. Right? Okay. So with that, we can start to use that to help us describe and understand some things a little bit better. So a sequence of numbers is simply a number pattern. So this here is a number pattern because 3 plus 1 is 4, plus 1 is 5. So forth and so on. You can figure out what the pattern is on this. All right. The above sequence can be described as the first row has 3 bricks, and each successive row or row below will have 1 more brick. Right? And then, again, I know you're saying, "Wow, that's fascinating." Yes. Well, that's how you describe the sequence of numbers. Okay. So let's take a look at an example, and we'll take a look at an example in a minute, I guess. First off, explicit formula. So this is the general formula to find any term in that sequence. Okay? So, for example, the explicit formula for the brick problem is u sub n. That's considered to be we call that the nth term. And then each row is increasing by 1. So that's 1 times n. And then 2 is how much you have to add or subtract to get the first row. So for example, if you'll remember, our numbers were, what were they? Were 3 and then 4 and then 5. So again, it's going up by 1 each time, so that's where the 1 comes from. So we say u sub n equals 1 times n. Right? And then now if you plug in 1 for the n, you go 1 times 1 is 1. And that does not give you 3, so we have to say, okay, what do we add or subtract to that to get to where we want to be? And we need to add 2 to that to get up to 3. Okay. So then to find the second row, you would plug in 2. 1 times 2 is 2, plus 2 is 4. And then to find the third row, we plug in 3 for n. 1 times 3 is 3, plus 2 is 5. So this here, this u sub n equals 1n plus 2, is the explicit formula. Okay? So now, with that, let's take a look at an example. Okay, so we are going to write the explicit formula for the sequence 2, 6, 10, 14, so forth and so on. All right. So let's see. First thing I think that I want to try is I'm going to figure out what the difference is for each one. So 2 plus 4 is 6. 6 plus 4 is 10. 10 plus 4 is 14. So we figured out that it's going up by 4 each time. Okay. So u sub n is going to be, again, it's going up by 4 each time, so I'm going to put 4 times n. Okay? Now, honestly, what I do is I just plug in 1 and see if it works. So I'm going to say u sub 1 equals 4 times 1, which just gives us 4. Right? So this whole thing equals 4. That's not what we want. We want to have 2. So then we say, okay, we must have to subtract 2 to figure out what our actual u sub n is. So let's try that. So if we did u sub 1 equals 4 times 1 minus 2, that in fact gives us 2. Let's double check it with the other ones to make sure. U sub 2 equals 4 times 2 minus 2. So that's what? 8 minus 2. Which gives us 6. So these both work. Let's try, say, u sub 4 just to make sure. 4 times 4 minus 2, so that is what, 16 minus 2, which is 14, which is the fourth term. So now we know that we have the explicit formula for this sequence. And again, it's u sub n equals 4n minus 2. So maybe write the explicit formula for the sequence is u sub n equals 4n minus 2. All right, and that whole thing there is going to be our answer. All right. Okay, let's take a look at another example, and then away we go. All right. Let's see. Let's again. Well, you know what? We're not going to look at another example. We're going to just talk about a few little terms here, which is going to help us figure out everything that we need to know in 12b. All right. So 3 terms. First one, arithmetic sequence. It's a sequence where you add or subtract the same number to get the next number in the sequence. Okay, like the ones that we were just doing, those would be considered arithmetic sequences because we're adding the same number each time. Like the brick one, we added 1 to each row. The next example, we added 4 to get to the next one, to get to the next term. So those are considered arithmetic sequences. Something else we're going to take a look at is, well, not in this section, but in future sections here, is a geometric sequence. Okay, it's a sequence where you multiply or divide by the same number to get the next number in the sequence. So multiply by 2, multiply by 4, multiply by half, which is the same thing as dividing by 2. So those would all be geometric sequences, and we had an example of that in the 12a section. Okay, and then the last thing is number sequence, a set of numbers defined by a rule for positive integers. Okay, so basically that's really what we were figuring out with our general term. Okay, is we were figuring out a set of numbers defined by a rule for positive integers. Okay, so the positive integers really is the nth term. So like the first term, second term, third term, fourth term. So that is what this number sequence is talking all about. Okay, so you should now be able to say I can find the terms of arithmetic and geometric sequences when given the general term, which is the formula. All right. If you have any questions, please feel free to ask. Thanks.